Welcome to Lesson 8. In Lesson 8, we will discuss division of fractions and then review all four operations: adding, subtracting, multiplying, and dividing fractions. Before we start talking about the process we use to divide fractions, we need to look at some problems and find a pattern. Our first visual shows us four multiplication problems with the multiplier missing. That is a question mark. What I'd like you to do is two things. Turn the tape off and figure out what number replaces the question mark in each problem, and then look for a pattern. And when you see a pattern, after having worked the four problems, come on back and we'll discuss the pattern that I see. Well, you should have done this. 5 times 1/5 is 1, because the 5's cancel. 17 times 1/17 equals 1. 1/2 times 2 equals 1. And 3/5 times 5/3, since the 5's cancel, the 3 cancels, that equals 1. What was the pattern? The pattern was that in every case, in order to multiply the number by another number and get 1, we actually exchanged the numerator and denominator, because we can write 5 as 5 over 1. We flipped it over, 1/5 multiplied, got 1. 17 over 1, flipped it over. 1/17 times 17 is 1. 1/2 becomes 2 over 1, or 2, so 2 times 1/2 is 1. And 3/5, we exchanged the numerator and denominator and got 5/3, and 5/3 times 3/5 equals 1. There is a very special name for the fraction we get when we flip it over, when we exchange the numerator and denominator. It is called the reciprocal. Now, in many of my classes, we call it the flip. It's so much easier to say, but the official mathematical term is reciprocal. That is going to become quite important. By the way, there is one number that does not have a reciprocal. That number is 0. Hopefully you said 0 with me. Why does 0 have no reciprocal? Because 1 over 0, we can't do that. If you recall, when we talked about dividing by 0, we said that any number other than 0 divided by 0 is undefined. And therefore, since the reciprocal of 0 would be 1 over 0, and that's undefined, 0 does not have a reciprocal, which is very fine, because we will use the notion of reciprocal to divide, and obviously we cannot divide by 0. Now let's look for a pattern among division problems. The next visual shows us 3 division problems with 3 matching multiplication problems. Work the problems out, and again, look for a pattern. And when you've worked all 6 of the actual computations and see a pattern, come on back to the tape here, and we'll discuss the answers and the pattern that you should see. Okay. As we see, we can certainly, the division problems, 8 divided by 2 is 4. Now, notice the whole numbers are written as fractions, 8 over 1 and 2 over 1, but still the answer is 4. 12 divided by 3 is 4, and 15 divided by 5 is 3. The matching multiplication problems, we can cancel, and we get the same answers. 8 times 1/2 is 4, 12 times 1/3 is 4, and 15 times 1/5 is 3. Now, before we discuss the pattern, I want you to take a look at this next problem. 5/7 divided by 2/3. I want you to use the pattern you thought you saw to do this division problem. And then come on back to the tape and we'll see if you had the right pattern. Well, the pattern that you should have seen is that dividing by a number is the same as multiplying by its reciprocal. That is, dividing by 2 is the same as multiplying by 1/2. Dividing by 3 is the same as multiplying by 1/3. Dividing by 5 is the same as multiplying by 1/5. And therefore, dividing by 2/3 is the same as multiplying by 3/2. So we've changed the 5/7 divided by 2/3 to a multiplication problem, 5/7 times 3/2. We already know how to do that from less than 7. We cannot cancel. We multiply, we get 15/14, and the answer is 1 1/14. So 5/7 divided by 2/3 is 1 1/14. Let's take a look at some additional problems and to see exactly the process we use for dividing fractions. The next problem is 5 1/7 divided by 2 2/3. Okay. This problem is a little different than the 5/7 divided by 2/3 because we have mixed numbers. What are we going to do? Well, we know eventually we're going to multiply. We know that. We know we're going to have to get the reciprocal of the second number. In both cases, we need to get fractions. To multiply mixed numbers, we need to change them to fractions. To get a reciprocal of a number, we have to write it as a fraction so we can exchange the numerator and denominator. So the first step here will be exactly the first step as we did in multiplication, and that is to change the numbers to fractions. Again, the consistency of mathematics. We said before that division is really the opposite of multiplication and should have very similar rules. And indeed, in this case, we have the same first step. Change the mixed numbers to fractions. Well, 5 1/7 is 36/7. 2 2/3 is 8/3. Once we have the numbers changed to fractions, we now can use the pattern we saw earlier. Dividing by a number gives us the same answer as, if you will, multiplying by its reciprocal. What is the reciprocal of 8/3? 3/8. So 36/7 divided by 8/3 is the same as 36/7 multiplied by 3/8. And now we're back to multiplication. We cancel, which of course we could do with the 36 and the 8 dividing both by 4. We multiply numerators and denominators, get 27/14, and we have our answer. Once we've simplified 27/14 to 1 13/14. And now it's time to check. We are dividing 5 1/7 by 2 2/3. We could say we're dividing 6 by 3, so our answer should be around 2. More importantly, we're dividing a larger number by a smaller number, so we should get a number more than 1. Our answer of 1 13/14 is certainly close to 2, and it's certainly more than 1. So that's one way to check. But notice our answer is more than 1. Okay, we divided a larger by a smaller. Let's take a look at another type of division problem involving fractional numbers. In this case, we're going to be dividing by a proper fraction. 8 1/3 divided by 5/8. The steps are identical. The first step, change the numbers to fractions. We don't have to change 5/8 to a fraction. It already is a fraction. But 8 1/3 becomes 25/3. Now that we have fractions, our next step is dividing by a number is the same as multiplying by its reciprocal. Well, let's see. The reciprocal of 5/8 is 8/5. So now we have a multiplication problem, 25/3 times 8/5. We cancel, dividing both 25 and 5 by 5. Multiply numerators, multiply denominators, we get 40/3. That's an improper fraction. We simplify and get 13 1/3. When we divide by a proper fraction, that is the same as multiplying by its reciprocal. The reciprocal of a proper fraction must be an improper fraction. Let me say that again. The reciprocal of a proper fraction must be an improper fraction because the proper fraction has a larger denominator, the numerator. When I flip it over to get the reciprocal, the larger number is now in the numerator, so it's improper. So dividing by a proper fraction is the same as multiplying by an improper fraction. Thus, the answer will be larger than the other number. That is, if we divide 8 1/3 by 5/8, we should get a number larger than 8 1/3 because 5/8 is a proper fraction. And obviously 13 1/3 is a larger number than 8 1/3. Okay, let's take a look at one more type of problem. In this problem, you'll notice we're dividing a smaller number by a larger number. They're both mixed numbers, but the second number is the greater number. Okay, we have 2 and 2/5 2 and 2/5 divided by 5 and 1/3. Okay, first step, still the same. Change the numbers to fractions. 12/5 divided by 16/3. Over the many years of teaching this, a number of my students try to do two steps at once. They try to both change it to fractions and do the second step of flipping over the second number. Please don't do that. I have found that that typically leads to mistakes, and it's much easier to go back over your work if you've done it step by step, not doing two steps at one time. Sometimes in a haste to get finished with the problem, we make mistakes. A wrong answer that's done quickly is not very good. A correct answer that's done efficiently is quite good. So we're going to take the number 12/5 divided by 16/3, and dividing by 16/3 is the same as multiplying by 3/16. We cancel. We can divide both 12 and 16 by 4, and we get 3 times 3 is 9, 5 times 4 is 20. It's a proper fraction. We cannot reduce it since we've already canceled in the multiplication process. But notice, why did we get a proper fraction? Because when we divide a smaller number by a greater number, the answer must be less than 1. It must be a proper fraction. And that's how we check this type of problem. So in checking division problems involving fractions, we want to look at the nature of the numbers we're dividing by. If we're dividing a larger number by a smaller number, our answer will be less than the first number, but more than 1. If we're dividing by a fraction, a proper fraction, our answer will be bigger than the first number. And if we're dividing a smaller number by a larger number, our answer should be a proper fraction. Okay. Let's take a look at a few problems. So we'll go to the whiteboard and see if we know what we're doing here. Okay, the first problem, and again, we'll do a few division problems, and then we, as promised, we'll review fractions typically. Let's see, 6 1/2 divided by 3 1/4. I'd like you to work that problem after stopping the tape. Be sure to check the answer that it's reasonable, and come on back when you've finished your work, and we'll go over it at the whiteboard. Okay, 6 1/2, we need to change to a improper fraction, 13/2. Divided by, we need to change 3 1/4 to improper fraction, 13/4. Again, remembering that the first step is change all numbers to fractions. The second step in the division process is to remember that dividing by a number is the same as multiplying by its reciprocal. So 13/2 times 4/13. The reciprocal of 13/4 is 4/13. By the way, I should mention that sometimes people get confused about which number to reciprocate. If you simply recall that the words were dividing by a number is the same as multiplying by its reciprocal, the number we divide by is always the second number. So that's the second number is what we reciprocate. By the way, probably if you flip over the first number, you'll realize your answer is incorrect. It will not be reasonable. But the easiest thing to do is remember, dividing by a number is the same as multiplying by its reciprocal. Well, we're not finished yet. We need to cancel. 4 and 2 can both be divided by 2. 13 can be divided by 13. That makes this problem rather nice, because we're left with is 1 times 2, which is 2, over 1 times 1, which is 1, and that gives us an answer of 2, the whole number 2. Does that make sense? Well, we're dividing a larger number by a smaller number, so our answer should be smaller than 6 1/2, but more than 1. And in terms of estimation, 6 divided by 3 is 2. Hey, we got 2. That's pretty good. By the way, what that means, you're talking about the meaning of the answer, is that 6 1/2, of course, is twice 3 1/4. Another way, of course, to check, as always, is to multiply your answer by the number you divided by, and you should get the number you started with. In this particular case, that's rather simple. 2 times 3 is 6. 2 times 1/4 is 2/4, which is a half. So if you get an answer of 2, it means the first number is twice the number you're dividing by. Okay, let's try another problem. And this problem is 9 1/7 divided by 8/11. Okay. Same process. Stop the tape, work the problem, check it for reasonableness, and come on back. Okay, first step, always the same. Change the numbers to fractions. 9 1/7. Let's see, 9 times 7 is 63, and 1 is 64/7. 8/11 is already a proper fraction. We just leave it alone. Next step, dividing by 8/11 is the same as multiplying by its reciprocal, 11/8. 64/7 times 11/8. The next step is to cancel, if we can. We cannot cancel 7 and 11. The only number that divides 7 other than 1 is 7, and certainly 7 does not divide 11. But 64 and 8 are both even numbers. But even more importantly, they're both in the 8 times table. We can divide by 8, and we get 8 and 1. By the way, if you simply divide it by 2, and then by 2, and then by 2 again, that's okay, as long as you get the complete cancellation, and you get 8 and 1. And now we multiply across. 8 times 11 is 88. 7 times 1 is 7. 88/7 is an improper fraction, and we're going to have to simplify. Well, let's see. 7 goes into 88 12 times. 12 times 7 is 84. We have a remainder of 4, so 12 4/7 is our answer. Now, does that make sense? Well, let's go back to our original problem. 9 1/7 divided by 8/11. When we're dividing by a proper fraction, our answer is always going to be larger than the number that we're dividing into. Larger than, in this case, than 9 1/7. 12 4/7 certainly is larger than 9 1/7. Now remember, it's only true when we divide by a proper fraction, and we go back and look at the first number and ensure that our answer is a greater number. So this looks good. In fact, it is the correct answer. Let's do one more problem. Okay. Let's see. How about this problem? This is a problem we haven't really looked at before. Divided by 3 1/5. What we haven't seen before is where the first number is a proper fraction. I'll let you figure out what the pattern might be. Go ahead and divide, see if you can estimate, check your answer, and then come on back, start the tape up again. Okay, let's just go ahead and use our steps, and then we'll go back and look for a pattern here. 9/10 is already a fraction. 3 1/5 is 16/5. Now, at this point in time, some of my students want to cancel because they see the 10 and the 16 and say, hey, we can cancel. No, you can't. The only time you can cancel is when you are multiplying. You cannot cancel in any other type of fractional problem except multiplication. So we need to follow our steps. The next step after changing the numbers to fractions is remembering that dividing by a number is the same as multiplying by its reciprocal. So 9/10 we leave alone. Dividing by 16/5 is the same as multiplying by 5/16. Okay. We can cancel. Not the 9 and the 16, but the 10 and the 5 can be divided by 5. We multiply. 9 times 1 is 9. 2 times 16 is 32. And our answer is 9/32. Let's go back to our original problem. In reality, we have seen this type of problem before. We just hadn't seen one with a proper fraction as the first number. Because we said when you're dividing a smaller number by a greater number, the answer must be a proper fraction. Certainly 3 1/5 is greater than 9/10, and therefore our answer is a proper fraction, and in fact is less than 9/10. And certainly 9/32 is a lot less than 9/10. Okay. Now it's time to review what we've done in these last few lessons on fractions. So let's go back, and I think the best way to review is to work a problem and make sure that you remember how to do it. And if at any point in time, any of these problems, adding, subtracting, or multiplying, you have forgotten how to do, well, go back and watch the appropriate lesson again to ensure you can do it. First, let's take a look at an addition problem. How about 9 3/4 plus 7 5/6? Okay. What I'd like you to do is stop the tape, work the problem. We'll come back, work it together, and to ensure that you remember how to add mixed numbers. Stop the tape now, please. Okay. First thing we need to do, the first step in adding mixed numbers or fractions, is to get a common denominator. I'm going to write down the 9 and the plus and the 7. We could use 24, 4 times 6, but I'm going to use the lowest common denominator, which of course is 12. Completing the equivalent fractions, 4 times 3 is 12, 3 times 3 is 9. 6 times 2 is 12, 5 times 2 is 10. And now, since I have a common denominator, I can add. 9 and 10 is 19 twelfths. 9 plus 7 is 16. I have an improper fraction. I know that when I add two proper fractions, I get an improper fraction. When I simplify, the whole number has to be 1. I add the 1 to the 16, I get 17. What's left? 19 minus 12 leaves me 7 twelfths. My last step is to see if I can reduce. Can I reduce 7 twelfths? Well, I know that the only number that divides 7 other than 1 is 7, and 7 does not divide 12. So our answer is 17 7 twelfths. As I referred to earlier, if I wanted to check this problem, I would just say, well, gee whiz, 9 plus 7 is 16, so the answer is either going to be 16 and a fraction or 17 and a fraction. And of course, it is 17 7 twelfths, so the answer makes good sense. Let's take a look at a subtraction problem. Erase this. Okay, a subtraction problem. How about 9 1/8 minus 2 5/6? Go ahead and work that problem out and come on back, turn the tape back on after you've completed the computation. The first step in subtracting, just as in adding, is to get the common denominator. But I'll write down my whole numbers and my subtraction minus sign. The common denominator, well, I could use 8 times 6, which of course is 48, but I'll again choose to use the lowest common denominator, which would be 24. My next step is to get the numerators to have equivalent fractions. 8 times 3 is 24, 1 times 3 is 3. 6 times 4 is 24. 5 times 4 is 20. The next step is to borrow if needed. Do I need to borrow? Yes, I do. I cannot subtract 3 minus 20. So I borrow 1 from the 9, making it 8, and then I simply add the 24, since 24 24ths is what 1 is equivalent to the 3 24ths, and I get 27 24ths. Then I subtract. 27 minus 20 is 7 24ths. 8 minus 2 is 6. And the final step in subtraction is to reduce if possible. Can I reduce? Nope. Again, I have a 7, and I know the only number other than 1 that divides 7 is 7, and 7 does not divide 24. So my answer is finished. It's correct. Again, 9 minus 2 is 7, so my answer should be either 7 and a fraction or possibly 6 and a fraction, and it is 6 7 24ths. Okay, let's try a multiplication problem and see if you recall from the previous lesson how to do that. 5 5/8 times 2 1/9. Go ahead and try that. 5 5/8 times 2 1/9. When you finish, come on back, we'll work the problem out. The first step in multiplication is to change the numbers to fractions. Okay? 8 times 5 is 40, plus 5 is 45 eighths. 9 times 2 is 18, and 1 is 19 ninths. The second step is to cancel if possible. Well, 8 and 19 have no common number that divides them. 2 divides 8, but 2 does not divide 19. In fact, 19 is one of those numbers that can only be divided by 1 in itself. But 45 and 9 can be canceled because both are divisible by 9. 9 goes into 45 5 times. 9 goes into 9 one time. And now I can multiply. 5 times 19 is 95. 8 times 1 is 8. This is an improper fraction, so I simplify. 8 goes into 95. Let's see, goes in, about 11 times. And with a remainder of 7, which gives us 7 eighths. 11 and 7 eighths. Again, checking by estimating. 5 times 2 is 10. More than 10. 6 times 3 is 18. The answer should be between 10 and 18, and it is. Hopefully you got all those questions, answers correctly. And now we have completed our study of fractions. We know how to add. We know about the common denominator. We know how to subtract, also using the common denominator. We understand how to multiply and, of course, understand how to divide. Next, it's on to Lesson 9 and decimals.